Everyone talks about quantum computers. Almost nobody talks about how they will connect. A room full of isolated quantum processors is a museum. The real prize is a network that moves quantum information, shared entanglement, ultra-secure keys, and precision timing between cities, labs, and eventually continents. That is quantum networking. It is the plumbing behind the quantum internet headlines. And in 2026, the plumbing is where serious money and serious pilots are landing. Today we map the stack from quantum key distribution to entanglement links, and what is actually live versus still lab only. First misconception to kill. Quantum networking is not about downloading movies faster. Classical fiber already moves bits at incredible speed. Quantum networks move different assets. Cryptographic keys generated by quantum physics, so eavesdropping leaves evidence. Entangled pairs shared between distant nodes, so joint measurements correlate in ways classical links cannot fake. Ultra-stable timing signals for GPS, finance, and sensor arrays. You are not replacing the internet. You are adding a trust and physics layer on top of it. Think secure keys plus entanglement distribution, not quantum Wi-Fi. The most deployed piece today is quantum key distribution, QKD. Alice and Bob, the classic names, need a shared secret key. A quantum channel sends photons. If Eve tries to intercept and measure them, she disturbs the quantum states. Alice and Bob detect the disturbance and discard compromised key material. The math has been known for decades. The engineering is hard. You need single photon sources, low-loss fiber or satellite links, and classical authentication to prevent man-in-the-middle swaps. But commercial QKD systems exist. Banks, governments, and telecom labs run field trials. This is the first quantum network product you can actually buy. The harder prize is distributing entanglement itself. Entangled qubits shared between remote nodes enable distributed quantum computing and advanced sensing protocols. Problem: entanglement is fragile. Fiber loss kills it fast. Quantum repeaters, still mostly research, aim to extend range by entanglement swapping at intermediate stations. Satellites have already demonstrated entanglement over thousands of kilometers, bridging ground stations that could never link by fiber alone. In 2026, city-scale entanglement demos are real. Nationwide entanglement backbones are still engineering programs, not products you order on Tuesday. Quantum networking is not only keys and entanglement. Precision timing links matter. Atomic and optical clocks synchronized over quantum-grade links support navigation, science, and financial networks where nanoseconds equal millions. Quantum memories, devices that briefly store quantum states, act as buffers so networks can route entanglement asynchronously instead of demanding perfect simultaneous arrival. And yes, quantum sensors feed the network story too. Sensor arrays generating data that quantum links secure and timestamp. The quantum internet is an ecosystem. Computers, sensors, clocks, and fibers working together. What is live in 2026? Live 1. Commercial and pilot QKD links operated by telecom and government partners in Europe, Asia, and North America. Live 2. Published satellite entanglement and QKD experiments with documented distances and error rates. Live 3. National quantum network testbeds where universities and industry plug in hardware under real latency and loss. Live 4. Standards work tying post-quantum cryptography migration to hybrid classical quantum security architectures. Not live yet, a consumer quantum internet replacing your home router. Not live yet, entanglement repeaters in every telecom closet. Watch contracts and published link distances. That is how you separate pilots from posters. Here is the frame to keep. Quantum advantage is not only a chip milestone. It is a network milestone. The team that links secure keys today and entanglement tomorrow owns the infrastructure every other quantum application rides on. Your move: track QKD deployments, repeater research milestones, and testbed participants by name. That is the supply chain of the quantum era. Tune in tomorrow, we break down quantum error correction, the engineering problem standing between today's noisy machines and tomorrow's useful ones. Subscribe if you want the future without the fluff.